Hello scholars, welcome. Mr. Hinkle here to talk to you about benthic communities on rocky shores. We'll even sneak in offshore communities. So our objective is to discuss these communities, and we are going to provide examples of the different types of organisms and some of their marine adaptations, because this is the name of the game for marine life. There's an environment, and how do they adapt? Let's get into it. So rocky shores are going to be rocky, which means that the bottom is made of solid rock, there's no sediment on top, and thus the organisms that exist here live on top of the floor or on top of the substrate, which classifies them as a specific type of benthic organism called epifauna. Epi meaning outdoor or outer or exterior. So benthic organisms are epifauna classified by intertidal zonation. What does that mean? Well, every single day, the Earth spins. Once every roughly 24 hours on a fixed axis. Every single year, the Earth orbits around the sun. These two features in combination give Earth its unique seasons, but also the location of the Earth and the sun and the moon relative to each other exerts specific forces of gravity that pull on Earth's water, creating Earth's tides. It's a pretty cool thing. In application, what that does is it means that where the water meets the land, the shoreline moves. It moves up and it moves down every single day. It's varied by location depending on the shape of the coastline, the continents, the oceanic currents. There's a few different factors that go into it, but for the most part, we have high tide, a relatively dry zone, middle tide, covered by all high tides, exposed by all low tides, and low tide, which is usually wet. We also have above the high tide and below the low tide, giving us a zonation. I like these images. These are this is the diagram, a couple different diagrams of communities on rocky shores, where specific organisms live below the low tide, in the low tide zone, in the middle tide zone, in the high tide zone, and then we even have organisms that come up and live above the high tide zone, the supratidal zone. Okay, so let's go into this. The supratidal, or above, is going to be classified by organisms that don't dry out. Many of them have shells. There's not very many species of marine algae, and we've got examples here of the rock louse and limpets, as we can see in our images here. A limpet, look at that, with the shell. What is this? Oh, it's a snail, a very common snail that lives in the supratidal zone. Okay. High tide. These animals have shells to avoid from drying out. Here we've got marine algae, rockweeds with thick seawalls. Barnacles and mussels are going to be primary high tide. They also live in the middle tide. Here's the thing. It's a spectrum. So it's not a zonation like sea stars only live in the middle tide zone. No, they can also spend time in low tide, spend time in high tide. Same with mussels and barnacles. But for example, we have specific adaptations to specific zones. So in our high tide, common species are barnacles and mussels. Continuing our voyage through the tides, we move into the middle tide zone, where we have a much higher biomass. Because it's always dry and always wet in the middle, organisms have increased or a multitude of adaptations for surviving in here. Here we see also barnacles, mussels, carnivorous snails, and sea stars. Middle tide. Sea stars are so cool. Here, organisms need to be able to withstand drying out and being wet. So they have adaptations for attaching to the seafloor so they don't get swept off by the big waves, but then they also are okay when the tide is low and they avoid drying out. Going down into low tides, now we have some cool things. Sea anemones. These are some of my favorites. If you touch the anemone, it will go kind of retract back into itself. Don't worry, these are not stinging nematocysts like we see on our jellies or our Portuguese man-o-war, the scyphozoans of our pelagic animals. Let's go here, low tide. And we'll put in here anemones. You can draw some pictures. What do we got? Some rocks with mussels. And then here we've got snails. My rough caricatures of marine organisms. Still waiting on taking that art class. I'll let you know when it happens. Okay. Shore crabs. So in this low tide zone, wait, did I go the wrong way? Yeah, middle tide, boom. Low tide, shore crabs, seagrass. There's various organisms here. I think I put the anemones in the wrong spot. Whoop. Anemones. Down here we've got crabs, seagrass. All right. Excellent. So down here we've got scavengers that feed on algae, hard exoskeletons, different types of adaptations for the low tide zone. When we move offshore, so this is going to be the subtidal zone, or areas that are always wet. And two unique habitats that we have occurring here are coral reefs. We have an entire segment on, in its own individual lecture on coral reefs, but extremely diverse ecosystems, keystone species created by coral polyps that support very high levels of biodiversity and productivity. We also have kelp forests, which provide habitat and protection for a variety of different marine organisms. Kelp being a form of macroscopic algae, a primary producer, plants of the ocean, with its own types of marine organisms. Here we've got oysters and lobsters. Oysters, lobsters. Lobsters are so cool. So in conclusion, benthic organisms are an important component of marine food webs, and most importantly, in these rocky shores and offshore environments, we have a multitude of different organisms that exist that have adapted to the variable conditions to avoid drying out, to being inundated all the time, and to spending half their time wet and half their time dry. So this is Communities on Rocky Shores in the benthic environment. Thank you so much, and I'll see you again.